participants are joining.
Here. Hope you all are doing well and staying safe. Greetings from the team Petroleum Engineers Association. I am Niharika from Team PEA. Welcome to this free introductory session on our upcoming 3 days course, Coiled Tubing by Engineer Samir Sukhri, petroleum expert and an international Iwcf instructor. Our full course will start from 10th May 2021. Thank you for joining with us in this introductory session. Now, without wasting any further time, I would like Engineer Samir Sukhri sir to start this introductory session. Thank you. Over to you, sir.
Okay, thank you, Niharika. Thank you, Mr. Nikhil. Good afternoon. Hi, everybody. Today, we have the subject of coil tubing technology, principles, procedures, and troubleshooting. This is introductory session for today as a method of well intervention that we started 2 weeks ago with our series with the well life cycle. So it is a vital part of our operations in the maintenance phase. We have production. After production, we have maintenance. During this maintenance, we have to keep the reservoir producing, and in this case, we have to keep our production stable from this well. So this introductory session for today will last for 1 hour. After that, after 2 weeks from today, we will have the main course dated on 10th to 12th of May 2021. So I hope that you will get benefit today from this session and after 2 weeks from the main course for 3 days. Before this course, I delivered a question sheet including 63 questions about this subject. I hope that you had a look at them. And in the meantime, you did brainstorming and answered some of the questions, or some of you maybe answered most of them. I don't know the percentage, but it is a good chance to improve yourself and your knowledge. Especially most of you are young, maybe a student at the university, maybe recently graduated. It depends, maybe expert, so and so. So now I can introduce myself quickly. I am a petroleum engineer. I graduated in the university in 1995. I am Turkish. I have 25 years of experience in oil and gas, most of them in workover, well services, production engineering, well integrity, Iwcf certification, and I am authorized in oil and gas training from Scotland, from UK. I worked for several companies. Quickly we can see them. I started with workover supervisor with Syrian Petroleum Company, then moved to joint venture between Shell and Syrian Petroleum Company. This one, it is called Al Furat Petroleum Company. Then I moved to ADCO, Abu Dhabi Onshore Operations Company, onshore operations company. This one, then I moved to training for oil and gas and Iwcf. So I have these certificates for training from Scotland. So you see this one. So also you have these. If anybody from your colleagues or any training center wants to associate with me, so you can see these with me. You can go to LinkedIn and do connection with me. I will agree, I approve on it, because sometimes I put something useful videos, posts like this, also on Facebook. It is only for the work. YouTube also, I put videos so you can subscribe and like if you want. This is my email and my mobile. WhatsApp if you want. 4 positions. I have now these 3 positions: Iwcf instructor, well intervention, oil and gas trainer, and well services consultant. I work with Mr. Nikhil Petroleum Engineers Association in India, and these are the details. If you want anything about upcoming courses or any other courses, you can coordinate with Mr. Nikhil. He is the admin in the group, and this is his mobile number. You see it. So he is very hard worker man. I really appreciate him. We'll go to our agenda for today. Introduction to coil tubing, introduction to Iwcf. Also, I want to give you an introduction of how to be certified for Iwcf, because if you don't hold this certificate, you cannot work in the oil and gas field. So it is very important. Also, calculations for well control. We have introduction to well and completion types, completion components, wellhead, wiring operations that can be done before moving the coil tubing to the well site. We have coil tubing definition and uses, safety of coil tubing, components of coil tubing package, standard rig-up of coil tubing equipment. Then coil tubing barrier theory. Also, we'll go into pressure control equipment. We have a primary barrier, secondary barrier, tertiary barrier. These are the 3 barriers: first line of defense, second line of defense, third line of defense, to work safely on the way. Typical coil tubing surface stack up also. We have coil tubing applications. We have these ones. We go through them one by one till 10 applications. Then we can discuss the working in H2S environment. We can have something about safety, risk assessment matrix. Quickly, we can look at it. Hazards, zone classification, personal protective equipment. These are very important information for you to enrich your knowledge. And without it, you cannot work in the oil field. Because you want to protect yourself and others. So we have life-saving roles. We can have a quick look at Macondo well, deep horizon disaster. This is the worst case scenario that happened in the world for spilling of oil to the surface as 4.9 million barrels of oil escaped from the reservoir to the surface uncontrollable. We can discuss also the incident of the 3 persons died in H2S incident. Coil tubing emergency response procedures. These are the total are 10. So if you want to work as coil tubing operator or assistant or supervisor, you have to memorize these cases by heart. So we have to go through them one by one. We have also experience exchange. You see here, I will share today only 7, and in the main course, they may be 17 cases. For the time being, we will utilize them. After that, we will go to more and more. So as I remember anything from my experience in the oil field, I worked since 1995 up to date, so 25 years plus. So I cannot remember them in one day. So every day I add 1, 2, 3, 1 like this. So after 2 weeks, they may become 30 cases. So this experience exchange will help you for the future and will catch the right way to improve yourself and to be a successful engineer if you want to work in the oil and gas section. We can start introduction to our course. What is coil tubing? Coil tubing is to provide well intervention services from surface to the reservoir and work instead of instead of bringing work over to the well site, we can move the coil tubing and run it to the downhole and do whatever we want. We can make a treatment for the reservoir. We can do isolation, fishing. We can do whatever we want. So we have too much variety of operation using the coil tubing. It is a very, very fantastic invention in the oil industry. And the sizes of coil tubing in use that I used 1 inch, 1.5 inch, 1 3/4, and 2 inch. This is in general, but there is less and there is more. But what I have dealt over my life, it is 1.5, 1 3/4, and 2 inch OD. So this technology is improving day by day. As you increase the OD, now you can use OD of 3.5 inch. So if you increase it, what will happen? There will be more capacity to pump higher volumes and higher capacities of fluids into the well. It can give you the capacity to make larger and bigger operations downhole. It can give you more ability to pull. If you want to fish, it can give you more ability to apply more tension. Instead of 40,000 pounds, you can use 90,000 pounds, for example. So it is a magic tool, I consider it, because you can save the workover sometimes from moving workover and do remedial actions, and you can save drilling operations by moving this one. It can be used onshore and offshore. It is very quick, and within 3 hours you can move it to the well site, rig up, pressure test, and be ready to run in hole. So it is easy and quick. It can be rigged up and rigged down within 1 or 2 hours, and it can be used onshore and offshore. Also, the depth that can be run into, we have this one till 25,000 recently feet, which is very huge. And if it is compared with workover, it is much cheaper. So you can depend on it. So every place in the world, you can find this coil tubing. You can work many operations in it. We can have a look at this video, please.
Approach to enhance completion efficiency. Weatherford's vast array of through tubing technologies, coiled tubing conveyance, and industry-leading composite bridge plugs can reduce trips in the wellbore and allow more efficient plug milling and.
So this is the coil tubing. We have here is the reel. Here is the control cabin. Here is also
wellbore cleaning. This animation will depict Weatherford's approach to the typical
injector head, BOP's Christmas tree
completion process. Once the well is drilled, cased, and cemented, typical completion operations would require 2 runs on coiled tubing.
You see?
One with a milling assembly to prepare the toe and clean up any residual cement, and a second with tubing conveyed perforating guns to perforate the toe, allowing
this is horizontal
well. Weatherford's Flowmax perforator allows this operation to be done in a single trip through the use of a flow-controlled valve, saving operators up to 30.
Here, after drilling, we run it and do milling for this cement, and After that, we will continue with the operation.
The cost for this routine wellbore service. After locating the cement obstruction at the well toe, circulation is increased to optimum milling rates to remove the cement and clean any debris. Once clear, the BHA can be pulled up hole to the initial perforating location. Flow rate is
So after milling the cement, this cement is resulting from the rig. So after removing it, we can pull the milling tool with the coil tubing up, and then we do the perforation.
Flow out the carbide jetting nozzles. Once at a jetting pressure, a sand slurry is introduced to begin jetting through the casing, cement, and extending a cavity into the reservoir.
You see, this is perforation.
This process can be repeated multiple times until the required quantity of perforations are made.
Using sand particles.
Flow is switched to clean fluid to flush the perforator. Then flow rate is decreased to open the valve and allow flow back to the motor, which can be reactivated to aid in wellbore clean-out of any residual sand material from the perforating operation. After the coiled tubing BHA is removed from the wellbore, proppant-laden frac fluids are pumped from surface to fracture the formation, as pressure builds beyond the compressive stress of the formation.
After perforation, we do frac. It seems that this video is long, so we'll restart it. No problem. We'll start again. 1 minute, please. Here, this one.
Approach to enhance completion efficiency. Weatherford's vast array of through.
We can talk in it in the main course, if you like. So the video, maybe some problem in the video. We cannot upload it very well. So we will move to the next slide. 1 minute, please. About the Iwcf certificate, we have 4 or 5 sections for Iwcf. We have completion equipment, completion operation, wireline operation, coil tubing, and snubbing. Snubbing is rarely used, so we can focus on coil tubing in this course and wireline. In the last time also, we focused on completion equipment and completion operation. We have levels, 4 levels for this certification, 1, 2, 3, 4. So the new ones may be introductory for them. After that, the operator, then the supervisor. Now we have these also calculations for weight control. These, I think you have them. You have to memorize them and keep them with you, because there are formulas very important for you to work in the oil field. So you can memorize them for calculating hydrostatic pressure, bottom hole pressure, reservoir pressure, specific gravity, API, oil density, water density. All of these you have to memorize them and keep them in your mind, also for calculations and volumes. We have 2 types of wells. Also, we can have an idea about the completion: vertical completion, vertical well, and horizontal well. Here also the completion components, we have them from top, from the Christmas tree to the formation. We have them one by one. Here also the safety valve, subsurface safety valve, it is very important to secure the well in case of an emergency. So we have these types of the mechanism of safety valve. This is a flapper type. Also we have ball and seat, but for this one, flapper type, we have flapper open. You see this flapper, it is open, the safety valve is open. When it is closed, the safety valve is closed. It is operated hydraulically from the surface. Surface control, subsurface safety valve. You will hear about it too much, so you have to learn these concepts and make your self familiar with them. Also, wellhead. We have wellhead that supports the casing head and tubing head, and at the top also we have the Christmas tree. These ones, this is the conventional Christmas tree. We have it normally 3 and 1/8 or 5 and 1/8, either 3,000 psi or 5,000 psi rated working pressure. Also another type, we have mono Christmas tree, and this also. You see 3 types of the wellhead, casing and casing wellhead, also casing here, and above it wellhead, and then Christmas tree. Here you imagine this is the actual well. You see how much it is big. The flames, studs and bolts, they are working here in the workshop. So we produce from here. This is wing valve and to the station. Here is the Christmas tree. Also, we mentioned these types of Christmas tree. This one, this is actual real Christmas tree. Here is the wellhead, and above it the Christmas tree. Here also you have to memorize all of these valves and know what's the name of this valve, what's the name of this. This is choke valve, like this. Here also the well will flow from here to the station. The station is here. We separate oil from gas and water. The gas is sent to the gas plant. The water is re-injected again into the well, and the oil is treated and produced or exported. We have, before we move coil tubing to the well site, we have to do some wireline operations just to ensure that the tubing is accessible and avoid the last minute surprise, so we can do drift run or accessibility run. If there is subsurface safety valve, wireline retrieval subsurface safety valve, we can retrieve it also before rig up the coil tubing equipment to the well head. Also, in some cases, we have to run wireline to measure the pressure or to collect downhole sample. It is fast. Wireline is faster and safer from the coil tubing. So if we have any obstruction or any problem in the well scale like this, we can obtain sample and send it to the lab to ensure that it is acid soluble and to choose which type of acid we have to use. Also, sometimes required to open and close the SSD sliding side door before running with coil tubing for reservoir isolation or communication. It may be required to set wireline plug for isolation also. So wireline is combined with coil tubing, and it can be utilized and very fast operation. Now we move on to the coil tubing. What is the coil tubing? Coil tubing is a continuous string of tubing rolled onto a spool. It is made from rolling strip material into a tubular. So it is metal, continuous metal. This metal is made up and welded in the factory by manufacturer, and welded, inspected, tested. All of these checks, then we choose the required length, for example, 20,000 feet, then send it to the user, to the end user, say Schlumberger or Baker Hughes or whoever, they can use it with this length. Sometimes they send 25,000, 15,000, it depends. So the coiled tubing industry is improving day by day, and it can save cost and save time, and it is efficient in the oil and gas industry. It has a wider acceptance in all operations involved in oil and gas exploration, especially in the highly deviated wells and horizontal wells. Because the wire line in these two cases cannot work properly. So we use coiled tubing. So it is used also when we want to pump chemicals into the well by pumping from the surface to the reservoir, for example, acid or treatment or anything to improve the reservoir productivity. And if there is a skin effect, it can remove the barrier that is formed between the reservoir and the wellbore, and allow the formation fluids to flow from the formation to the wellbore. This is called inflow. Then from the formation from the wellbore to the surface, it is called outflow. So this process can be improved by using the coiled tubing, because with wire line we cannot pump anything, fluids or like this, but with coiled tubing we can do all of this. If the well is equipped also, we due to its hydrostatic column, it is heavy, higher than formation pressure, we can pump nitrogen to offload the well hydrostatic head that is exerting on the formation. So here are 10 activities that can be performed using the coiled tubing. For example, logging, cementing, nitrogen kickoff, coiled tubing convey perforation, close and open SSD in horizontal completion, stimulation and fracturing, scale and sand clean out, milling, fishing, drilling, all of these. So very, very much variety of operations can be done using coiled tubing. So if you look at this, this is the coiled tubing package. We have control cabin. We saw it in the video. After that, we have the real unit power pack here. It provides the power to the unit. Also, we have here the gooseneck. We have the injector head, BOPs here, and Christmas tree. These are two wells you see near each other, this one and this one, two different operations, not one operation only. Here is a nitrogen unit, and this is nitrogen tank. The capacity is normally 2,000 US gallon of nitrogen, liquid nitrogen, and here is the nitrogen unit. We have a heater, heat exchanger, and it moves the liquid nitrogen to gas nitrogen. After that, it can be pumped. The boiling point of liquid nitrogen is minus 196 degrees Celsius. So it is very low. So in this at this temperature, we can move the nitrogen from liquid condition to the vapor or gas. After that, it can be pumped through the coiled tubing here, here the inlet, and it can go down to the required depth to offload the well, or maybe sometimes we have drilling, we have a clean out. If the pressure, hydrostatic pressure is high against the formation, what will happen? There will be a loss into the reservoir, and there will be no circulation to the surface to clean this sand or scale. In this case, the clean out operation will not be successful. What shall we use? We have to reduce the hydrostatic head against the formation. And in this case, we can make a circulation from the downhole to the surface by reducing the hydrostatic head using the nitrogen. This is a pumping unit. You see it. We have displacement tank here, 10 barrel by 10 barrel. And it is marked at this mark 1 barrel, 2 barrel, 5, 6, 6, 10 barrel, and this is 10 barrel. It is used for calibration also. Here is the control cabin for the pump operator, and here we can send the fluid that we need to pump. Here also we have a graph. This is the Christmas tree BOP. We have different types of BOP, injector head. This is the coil tubing. This is the crane. Sometimes you see that the crane is an integral part of the coil tubing package, same as hydraulic. Hydraulic has the same one. While in Stewart and Stevenson, the different manufacturer, you can see the crane is separate. So it is not integrated. Here we have the coil tubing, and here the reel, tubing reel, power pack. Here are the hoses to the BOP and to the injector head from this one. Here we have the control cabin also. We can monitor all what is happening on the wellhead and this area by the coil tubing operator. So it is under control. If there is leak here, he can see it. If there is parted tubing here, he can see it. So the clear vision is very important for the coil tubing operator to control. He is controlling the whole situation. Coil tubing application also, we can see this. I hope that it will not make a problem with us. You see, why coil tubing? We talked about this. In the course, we will talk more about them. You see cementing, drilling, stimulation, well control, completion. So overall of these, the advantages, he is mentioning the advantages, rigor breakdown, run, common applications, also removal of sand. We mentioned the nitrogen applications, acid, remedial completions, remedial cementing. You see this one, washing sand and fill. We'll go through them one by one, but for the time being, we cannot take, because it takes time. We have to be limited with 1 hour of our session. So you see scale removal, nitrogen bombing. Also, we offload part of the hydrostatic head against. Here there is water, we can offload it to allow the oil to flow. Stimulation treatment also, we pump acid and improve the productivity of this formation. Here see phone strings also. Remedial cementing, we can dump cement using the coil tubing. If here we have also fishing, we're using coil tubing. It needs much pull force, so we can use the coil tubing because we can go to 40,000 or 80,000 pounds. Here set and retrieve bridge plugs. You see isolation tool called the bridge plug. We can set it and pull it. Drilling composite bridge plug also. Inflatable packer also, we can isolate the bottom part from the upper part of the formation and allow it to produce. Logging, it is a vital part of our work, logging on coil tubing, especially in horizontal wells. It is safe and can be done. Also perforating conveyed with coil tubing. You see, we can also completions. We can run completion with coil tubing and set it in the well. Recompletion, high pressure coil tubing applications. Deviated applications also will work common. Need mechanical conveyance into lateral also. We have types, common cleaning tools, wash nozzle. We have fluid jetting nozzle, positive displacement, 3 types. Blocking issues. So all of these, we can go through them one by one. Use of polymers. This is also chemicals can be pumped into the reservoir to enhance its productivity. Safety of coil tubing. It is a vital practice of coil tubing or safety coil tubing to ensure that all components of coil tubing package are certified and checked. Each single part of coil tubing package should be checked and certified. If it is not valid, we have to reject it and request for another valid and inspected equipment. This includes the checks, function test, pressure test, equipment certificates from manufacturers. The incident of coil tubing could lead to damage. It can damage the equipment itself, can cause damage to the personnel working on it, and may lead to fatality. Also pollution to the environment. I will show you some videos now, and damage to the company reputation. You see, this is fire. You see it in the injector head. So our work is not easy at all, gents. We have to take care. So the training is requested all the time to improve your abilities. You see this one also. There is a thunder here. It can break this one and may break it into 2 pieces or like this. So always we do earthing cables to offload the static electricity or this thunder into the air. You see, the well is flowing here. So it is not a good scene, but this is the actual. Here also, there is a flow, uncontrolled flow, this one. You see this one, I will show you the video. You see there is gas here. So what we should do here in this case, we stop coil tubing.
Yeah, this is not good.
It is very dangerous, this situation. Any spark will make fire here in this area, in the injector head. So, and especially during the night, during the focus during the night is less than during the day.
I just saw something in the air. I thought it was just a butterfly or something in the air. Got a big one there.
You see, it is clear here. No. There is a stripper here below the injector head, and it is leaking. So we have to close this, stop coil tubing, close this BOP, pipe and the strip rams here in this area, and secure the well. Bleed off the pressure above it and replace the stripper above here. So it is not safe like this to continue. Quick action should be taken. Here, if you prepare yourself for dangerous situation, look at it, please. Here we are running in hole with coil tubing. Here is the injector head. Look what will happen. Look at here. You see? If anybody was walking near it, it will be disaster. Especially also if there is acid pump inside the coil tubing. So we have to take care. So the parts of the coil tubing package are control cabin. We mentioned it. Here, this one, power pack, this one, coil tubing reel, here, the coil tubing reel, gooseneck, this one, injector head, this one, stripper, this part, it is a primary barrier, BOPs, this one, this, and this, this is secondary, this is a quad BOP, and here tertiary barrier, which is shear seal BOP. And here we have kill line, you see it, kill line, and BHA in the end of the coil tubing. Here we have Christmas tree, and below it wellhead. We took it, this wellhead. Here coil tubing fundamentals. Also during the course, I can show you this video. You see, objectives. You see all of these. So we can move on to coil tubing rig up for logging on high pressure wells. You see, this is the rig up. It is not easy, not simple. It needs precautions. We have injector head, gooseneck, injector head, the stripper. We have blind and shear rounds. This one. This is a combi BOP, and the lower section is pipe and steel. Here also we have riser to include the tool string. We have deployment stack also. Here we can close this BOP on the deployment bar. Below it we have this also quad BOP, blind, shear, slip, and pipe rounds. We will take them in detail, and wellhead here. So we can run maybe 90 feet of wireline tool string and run it to the downhole safely and as per procedures. Coil tubing barrier theory. As coil tubing is a type of well intervention, so it needs minimum of 3 independent and tested barriers. We have a primary, secondary, and tertiary. We go through them one by one. You see primary, secondary, and tertiary, these one. We have a pressure containment. We will talk about the primary barrier and the types of it. We have 4 types. We have also the BHA. What is it consisting of? These parts. Also internal barrier, the types, main types of the check valve. We have flapper, dome, dart or dome, and ball and seat. We have other types, but these are the main types. We have also the secondary barriers. We have round type and annular type. We'll go through them one by one. You see them. This is a quad, this is a triple, and this is a combi. Here, if you want to cut the coil tubing, what will happen? We have sequence, close slip ram, close pipe ram, close shear ram, then pick up coil tubing 2 feet, then close the blind ram. In this case, we secure the well. We have annular BOP also. We'll go through them. You see, tertiary barrier. If primary and secondary barrier fail, that we have to activate the tertiary barrier, which is the shear seal BOP. It is cutting the coil tubing as if knife. You see it like a knife. It can close like this and seal, close and seal against the well. Here also the typical coil tubing stack from wellhead to the gooseneck, and each one is explained on the right side. Here, cement plug. How can you set dump cement for say 200 feet or 500 feet using the coil tubing? It is coming from the field experience. I was doing like this when I was working in the field. So I am exchanging my experience to you, so you can learn and do the same job maybe in a better way. Here we want to isolate full part or complete or part full formation interval or part of it. So we pump cement using the coil tubing, and in this case, we can produce it from the upper one. If there is water here, we can isolate it, and then oil and gas we can produce from the upper part. Here we have a mechanical bridge plug. We set it using electric line, wire line. You see wire line, electric line, a bridge plug. Here wire line retrievable bridge plug. Set it and dump 3 meters of cement or 10 feet of cement above it, just to make it hold. If the interval that should be isolated is very long, what should we do? We have to use this one. This is a question that I gave you, so you can answer this one. So nitrogen kickoff, also we run the coil tubing to a depth, say 2,000 feet, and start pumping from surface or from 500 feet at say 350 US gallon per minute of nitrogen, run in hole while pumping nitrogen. In this case, we will offload the fluid in the well. If it is water, this water will be produced, will be loaded off the well, and after that the reservoir fluid oil will be produced, and then we will get the well flowing. After that, we pull out of hole coil tubing and divert the well to flow and rig down our equipment. Here is the nitrogen tank. It is normally nitrogen, liquid nitrogen. It has 2,000 US gallon capacity. Here is the nitrogen pump. We have a heater, heat exchanger, and many pieces inside it. Radiator here, you see it. It moves it is boiling the liquid nitrogen and moving it to a gas condition. So after that, we can pump it here. You see this line from the nitrogen unit to here to the coil tubing, then downward. Nitrogen lifting also, we can see
back.
it.
In this training module, let's review nitrogen gas lifting with coiled tubing. The objective of this module is to provide a general understanding on gas lifting with coiled tubing. And the following subjects will be covered: why we would need gas lift,
Why?
well bore pressures, gas lift applications, basic procedures for gas lift operations, gas lifting variables, nitrogen rate optimization.
Why gas lift?
So, why we need gas lift? If bottom hole wellbore pressure is currently greater than the reservoir pressure, the fluid hydrostatic pressure will prevent the reservoir flow.
I told you that we offload this to outside
Let's
of the well.
discuss well-borne pressure relationships. There are 3 scenarios of well-borne pressure relationships. The first scenario, called overbalance,
Overbalance.
where the pressure inside of wellbore is greater than reservoir pressure, normally occurs when we're drilling a well. The second scenario, called underbalanced, where the pressure inside of wellbore is less than the reservoir pressure, normally occurring when we're producing the well. The third scenario is called balanced, where the pressure inside of wellbore is equal to reservoir pressure. This chart shows an example of wellbore pressure relationships. If we have reservoir pressure is 3,500 psi, the well will be overbalanced if wellbore pressure is 4,000 psi. The well will be balanced if the wellbore pressure is 3,500 psi, and the well is underbalanced if the wellbore pressure is 3,000 psi.
Gas lift of applications, well kickoff, well unloading.
Let's review gas lift applications. There are 2 purposes: expected fluid volumes, fluid properties, downhole restrictions, and fluid loss to formation. Variables that affect gas lifting operations are tubular size, well depth, fluid top depth, bottom hole pressure, bottom hole temperature, fluid properties, coiled tubing size, coiled tubing run and hole rate, nitrogen pump rate, and surface equipment back pressure.
All of these factors affecting to the performance of the
This
coil
chart
tubing.
shows an
Nitrogen.
example of optimizing nitrogen gas rate. The blue line is optimized until it reaches its peak. Eventually, if we pump nitrogen too fast, the wellhead pressure starts to decrease, even losing returns. The pink line represents larger coiled tubing size, increasing
So
annular
by
friction.
experience, we pump 350 US gallon per minute to 500 US gallon per minute. So it is within this criteria. So we can go through it in the course one by one. We have coil tubing conveyed perforation also, especially in horizontal wells. We run it and in 70 degrees and more inclination, and for the horizontal wells, where the electric line cannot be run. So we can perforate it either the live is well or it is coiled. So we have pressure control equipment. You see, these are the perforating guns and the phases of each one. Each one has phasing 45 degrees, sometimes 60 degrees. So we have to make it 360 degrees to cover all the tubing or the casing for perforating. Here also we have open and close SSDs in horizontal completion, as wire line cannot be run, and run shifting tool and open or close. You see it like this. This is horizontal completion. We can open the first one and close the third one, and like this. But here we have to all should open down and closing up, or the other option, all closing down and opening up. So we have to ensure this specification of the. So we don't run first, second, third. First run down to open, and the second one run up to open. This is wrong. So all of them should be same direction of opening, same direction of closing. Well stimulation, this is the most important operation that we can do on the well to enhance the productivity of the well or the injectivity also, because we have oil producer, oil producer, water injector, and gas producer, gas injector. So as we have a production, we have injection also. Why? To maintain the reservoir pressure high and keep flowing naturally of the well. We have two main types, techniques of stimulation: acidizing and hydraulic fracturing. Most of you have heard about acidizing stimulation and hydraulic fracturing. We can go through acidizing. What are the types of the acids that we can use? What are chemicals? Why? How can we pump acid? What is the purpose of pumping acid? Why do we pump hydrochloric acid for carbonates, and for sandstone we pump hydrochloric acid? All of these we'll discuss them in details. These you will see types of acid. We have organic acids and non-organic acids. HCl and HF are non-organic acids. While if we have high pressure, high temperature reservoirs, we use organic acids. Acetic acid, CH3COOH, and formic acid, HCOOH. These for high pressure, high temperature wells. For these ones, we have normal and low pressure wells. Additives, we have also corrosion inhibitor, friction reducer, surfactant, aerosequestering agent, diverting agent, non-emulsifier, anti-clay. All of these I will give you explanation about them one by one. You see, when we pump acid here, inject it in live well. After that, we flow back this spent acid. Then the well will produce. Here, the formation was a plug. Here, the formation is open. The productivity is enhanced. You see also. we have to improve the delta P. You see the delta P, the difference between formation pressure and bottom hole pressure. As this value increases, the productivity will increase. You see here the formation near the wellbore was contaminated, or there is a skin effect, or there is something preventing the formation fluids from moving from the formation to the wellbore. In this case, this is during for stimulation. This is the yellow one is the acid. Then these will allow the flow from the formation to the wellbore, then from the wellbore to the surface facility. Hydraulic fracturing also, we increase the pressure that is applied to the formation to above the frac pressure. We know that I will explain about the frac pressure if you don't know it. We have also to use fluid, water, propellant, gelling agent, foaming agent, compressed gases, nitrogen, CO2, air, corrosion inhibitors. All of these for the fracturing. You see fracturing stage also we make here, especially in this shale. You see this is shale, this one. It is not easy to open it, but with high pressure, you see the shale fracture, and we pump a propellant here between them. So when the pressure is dropped down, these spaces will be kept open using the propellant. You see water, sand. Propellant is type of artificial sand. So we pump it after making the frac in the formation, and allow the formation fluid to flow from the formation to the well, then to the surface. You see, this is a fracture here, propellant or artificial sand, or sand itself. You see, then we will allow it to flow, formation fluids to flow from the formation to the wellbore. You see, this is a frac operation. Imagine how much it is difficult, and what time does it take, what is the cost of it, all of these. You see, these are tankers for moving fluids to the well site, and it is 24 hours operation. You see, pumps, all of these are pumps. So no stop. As you stop, it will make the operation fail. You see, this is here also. This is wire line. Sand clean out also. We can talk about it using gel. We can use nitrogen if there is high pressure applied on the formation. We can explain all of these. We are taking a quick view now, but the details will be within 3 days. You see, this is casing tubing. We either pump from this coil tubing to the annulus, coil tubing annulus, or the vice versa, the opposite direction. From the annulus, we have to remove the BHA here. If we have the flapper check valve, it will not work. So when we have big coil tubing size, 2-inch and more, we can do this one. Otherwise, the coil tubing will be plugged. You see, this is the fill, sand here or scale, whatever. The milling also, we can, you saw the video, it is milling the cement. We can mill also the ball drop system that is done after setting the completion or the casing. We have bridge plugs also, we can mill them to go to the formation below the bridge plug. So the milling is interesting subject. We can move it. We have here the different tools that are used in the milling operation. You see, this is the bull nose. We can use it. We have motor here. You see, work over motor. This is motor stabilizer also for stabilization, and this is BHA. For fishing also, we can fish. For me, I was fishing the stuck wireline plug from the completion using this coil tubing and fishing tool. We were fishing it successfully. So in this case, we can utilize it. We apply till 40,000 pounds or more sometimes. But with wireline, you cannot go more than 2,000 pounds. So this gives us the ability to work very stronger. You see, all of these are fishing. These are fishing tools also. Jar, we have weight bar. We have all of these are run with the coil tubing connector. We have pumping. If you want to pump diesel, you want to pump fresh water, you want to pump, for example, acid, or like this, you have to, or solvent for the reservoir. If we have heavy oil in the reservoir, we can pump solvent, or we can pump chemicals. In this case, or polymers, we can pump it and then produce the oil. So pumping applications, we have these 9. This is, you can find it a question in your question sheet. We can move through them one by one. You have also, while working in H2S environment, all of these equipment, either wireline or coil tubing, it should be suitable for H2S environment. Otherwise, it will be embrittled due to the corrosive action of the hydrogen sulfide. It will be embrittled and will be failed, and we will lose our equipment. So you have to be familiar familiarize yourself with the characteristics of the H2S and know that it is corrosive. It has odor of rotten eggs. It is dangerous. It is produced with gas and water and heavier than air. It can accumulate in the low areas. It can kill the man at concentration of 1000 ppm. All of these, you can see them. You see, we have warning signs: very toxic, extremely flammable, dangerous to environment. So you have to, in UAE, I worked in a field that has one of the largest H2S percentages in the world, in the whole world. It reached to 37,000%, which means 370,000 ppm. If you can imagine, if 1,000 ppm can kill a man, what about 37%, which means 370,000 ppm, which means this 1,000 times 370. So it is terrible. It is very dangerous, and many people were killed during working on this in this environment of work, H2S. You see, here you have to work like this to protect yourself. Here we have air bottles. This is called Scba, self-contained breathing apparatus. So you can either work with it, Scba, or connect to these air bottles straight away and using a hose, and you can go to the wellhead. So, or also we have escape set 5 minutes. It is used just in case of your personal H2S monitor turns off alarms, then it can be used. Otherwise, if you have to work on wireline, it takes 5 minutes for rig up, rig down, or like this, or 10 minutes. You can use this one. While if you work in a confined space or a tank or like this, you have to connect this air bottle, these air bottles using hoses to you, and you can take a breath from through them. Risk assessment also, we have any risk associated with the hazard severity and hazard likelihood. So here is the more dangerous situation, here is acceptable. So always we try using this risk assessment matrix to reduce this red one to the green one here, or at least to yellow or brown. This one, why, or orange. Why? Because the principle is to make the work reduce the risk to alarm. Alarm means as low as reasonable, applicable. So in this case, we can reduce it to this level and put mitigations. So this is long. It needs more explanation. We cannot go through it now in details, but you have an idea about it. We have also classification for zones, zone 0, zone 1, zone 2. For coil tubing and wireline, we have zone 2 here. If you have flare, for example, it is zone 1. If you have a tank and roof above it, it is zone 0. Here is the definition of each one. Also, personal protective equipment, you have to use your shoes here, safety shoes. You have to use a coverall, gloves, goggles, ear protectors, helmet, and so on. All of these coverall, you see, all of these you have to protect yourself. Here also life-saving roles, it is known, we can go through them just to increase the awareness of your knowledge regarding safety. We can go to this incident that where 4.9 million of oil spilled into the sea in the Gulf of Mexico. We can give you some of explanation about it, you see, and 11 persons were killed in April. Now, 4 days ago, 5 days ago, this incident passed. We prayed for the 11 people who killed in this incident, and many were injured. This happened in 2010, 11 years ago, and 4.9 million barrel of oil spilled. You see this one, they drilled 2 relief wells and secured the well. Here we can pass it. Also, here we can talk about H2S incident. 3 people were killed. This is in 2009. We call it H2S silent killer. You see, the incident happened here. After that, EDCO in Abu Dhabi made videos and distributed it in all the world to avoid like such incident. As 3 people were killed and increased the awareness. So without this H2S training, you cannot work in any of these fields. This is the offshore fields. Offshore fields, these are, and these are the onshore fields in the Abu Dhabi, in UAE. So here is as I told you, I worked here in Bath field. It has very high H2S percentage, so the precautions were at the highest standard. So we were trained to deal with the high H2S and protect ourselves and others. Here we can see this video where was made by Adco about this incident. You see Adco, it is a very fantastic video, and it was delivered to all people in the world. You see,
2009 at Sharfield. A
Sharfield.
vital link in this chain
2009.
was broken.
These are the fields where I was working.
I came to work that morning. I saw my friend Ramesh feeding the bird. The rest of my colleagues were
This
busy in
died.
the workshop. No one was expecting the foreman Tariq to call us.
Foreman told us to come and finish a small job, and we would do the permit later.
You see, this man died in the scene.
The
Yeah.
team set off without a permit
No permit.
to work in a hazardous area. This was a deadly shortcut. It was to be their last journey.
Windsor.
Hydrogen sulfide, commonly known as H2S or rotten egg gas, is invisible, heavier than air, and deadly, even at low concentrations.
You see,
Ramesh descends into a toxic death trap.
it is a silent killer.
Ramesh was told to go down into the pit and fix the rope that had slipped off the valve. Then I saw him climb up the ladder to the second and third step, and then he fell down.
First one died.
The foreman called out to me, "Stop the pump." I didn't know what was going on. I could see Tariq trying to lift Ramesh up, and within less than a minute, Tariq had collapsed to the ground.
Second one collapsed.
Panic takes over. The air rushes down into the pit. Mustafa leaps down the other side, but the men have less than a minute of exposure to H2S before they fall unconscious.
Three people.
It was a big shock for me.
Every morning as we leave, we need to identify the hazard. And H2S is one of the big monitors on daily basis to eliminate it.
This was my boss. This one.
From this tragic incident, and we have engaged the whole organization to make sure that we do not face this kind of tragedies.
Anyway, we can jump here. We can last subject that we can take coiled tubing emergency response procedures. So these are most famous important cases that we can find in the coiled tubing operations. We can go through them one by one. You see, each one you have to do that. This one, so each one we can go through them one by one. Then I can come to here. I added this section, experience exchange, some problems with solutions that I faced during my work in the oil field. As I told you, 25 years I am working in this industry, and I faced many conditions and cases that I can transfer it to you. You see, this is the coiled tubing package. This one I can mention the first one. I tell you, I want to make it easy for you. I don't want to make it complex and don't cannot imagine it. You cannot imagine it. I don't like that. I want to make it simple and easy for you to understand, because some of you may not see any piece of equipment or didn't visit any oil field or like that. So I make it easy. I can discuss one by one. You see, this is the nitrogen. This is one. For example, I tell you that during nitrogen lift, you see this is nitrogen tank and this is nitrogen pump. While the coil tubing here in the well, we see that the flow line pressure that is producing the well has increased rapidly. In this case, what I did, I called the station and asked them what is happening for the supervisor. He told me we shut down the station prematurely. We don't it shut down by itself. So in this case, I stopped pumping nitrogen and waited till the station shut down, till the station returned back and continued the operation. In this case, we have to keep the pressure inside the coil tubing higher than the pressure outside to avoid the collapse of the coil tubing. Otherwise, the coil tubing will be collapsed and will be damaged. So even if we want to keep the coil tubing inside the well, we have to keep the pressure inside it higher or equal to the pressure in the annulus between coil tubing and tubing. And in this case, we protect the coil tubing from damaging it, and we can resume the operation after they fix the problem in the station. This is one case. It happened with me. I transfer, and I can talk more about it. You see, and we can talk about nitrogen, the specifications of nitrogen, what is it? Here, the boiling point, as I told you, liquid state at low temperature, minus 196 degrees Celsius. It can move from liquid to the gas at minus 196 degrees centigrade and move from liquid to gas status. And the gas status can be pumped into the well and lift the well. This is it is produced in we can obtain it from the air. Nitrogen has the proportion of 78% of the air volume, so it is lighter than air also. You see 78, this one 78% of volume, and it can be obstructed from the air, and it is slightly soluble in water. And inert gas, it is not dangerous. We can move it. Nitrogen has atomic number of 7. You see, here is nitrogen lifting. We inject gas into the coil tubing. You see coil tubing, and then allow the fluid to be produced from the annulus between coil tubing and tubing. Annulus here. Here is the tubing. Oil tubing, here the casing, here is the coil tubing. So when we produce this part, what will happen then? The fluid will be of the formation will be pushed up to the well and produce it through this annulus between coil tubing and the tubing annulus. So we reduce the hydrostatic head that is applied on the formation and will produce the well naturally. You see in the beginning, these are bubbles here of gas. After that, we have the slug, bubbly slugs. Then the slug annular transition, the percentage of the liquid is more, less nitrogen and more liquid, oil or water. Then only liquid, say oil, only oil. Here we have mist also. So this is the fluid drop. There are two forces that can be applied, down force, it is gravity here, and up force, it is caused by the nitrogen bubbles that are being pumped. So here normally we run coil tubing to depth, gas injection depth, normally in our company to 2,400 feet. This is a standard, 2,400 feet. Then stop here and allow the well to flow. Within 2 to 3 hours, the well will be offloaded. After offloading the well, what will happen? The passage from the reservoir to the surface will be open, and as if you are producing directly from the formation to the surface. Here also power pack got fired. It happened with me in say 2005, about 16 years ago, or 2004, I remember. We were working, suddenly this power pack got fired because there was leaking, hydraulic oil leak here, and we were doing a clean out. You have high temperature in this case, and the time was summer. So in the summertime, and the desert was temperature was 45 degrees centigrade. Temperature, high temperature, and oil, maybe sparking also. It is coming from where we did investigation about it. In this case, we controlled it using fire extinguishers, stopped the coil tubing, applied the brake, relay brake, and then replaced this power pack and continue our operation, and did full maintenance and redress. You see these actions which we did the full redress of the coil tubing unit. So I will discuss these in details also during clean out operation using 1.5 inch coil tubing. The pump heated up and then stopped working. It was coil tubing was downhole at 8,500 feet. Action, we go 1, 2, 3. You see, this is the fill. We were doing clean out either from this side or this side. And after that, we did the action, replace the pumping unit, and then continue the operation. We will finish, I think, here also. You see the clean out. We have different types of BHA. We can use these nozzles. Also, during nitrogen kickoff, we have these high temperature. We have buckling of the tubing, and in this case, the coil tubing got stuck. You see, when you have, this is the tubing. When it heats up, it will expand. When expanding, it will be like this. And inside it, there is coil tubing. It will be welded like this. So if it is welded like this, it will not be allowed to move up or down. In this case, we have to reduce. We stopped nitrogen lifting the well till the temperature dropped down. After that, we continued and pulled coil tubing out to surface. So all of these, we can discuss them also during clean out, stuck coil tubing. This one needs more and more explanation. It may need about half an hour because it has too many things. We cut the coil tubing. This we have to use this diagram. If we cannot pull the coil tubing to the surface, we have to cut it. If we cut, how can we cut it? We close the slip ram first, then pipe ram, then close the shear ram. After that, we pull coil tubing 2 feet, then close the blind ram. In this case, we secure the well and rig down the injector head and prepare for the next step. In our case, we run the coil tubing pressure here was 0 because the coil tubing was stuck. What did we do? We run a chemical cutter inside the coil tubing and cut it 500 feet above the stuck depth. In this case, we retrieve the piece of coil tubing above the stuck point. I will show you how did we cut it. You see this like this. We sent electrical signal to the chemical cutter. We have two types of cutting, either mechanical or chemical. Here cutting chemically by running chemical cutter, this one on the coil tubing. We have to fix it before we cut to avoid moving the tool here with coil tubing up or down using slips. We fix it. After that, we can send electrical signal to the chemical cutter, and we have here chemically charged. This chemical charge will has a very high temperature, and it will be directed to the coil tubing. In this case, what will happen? This is the diagram of cutting the tubing. We cut the tubing here in this one, but I told you about our case cutting the coil tubing in the same scenario. Also, we run wire line, only wire line, not coil tubing, wire line with a slip in it. Then we send electrical signal. So you can imagine this one similar to coil tubing and secure the well. You see, as if teeth here. You see, the other type of cutting is mechanical. You see, these can. We have a motor here. It can be rotated. We pump fresh water here at high rate and high temperature, high pressure. What will happen? This will rotate with these figures. How can be cut? I will show you how it can be cut.
When increasing pump rate during coiled tubing operations, the BHA along with the coiled tubing will move up or down. This makes it difficult to keep the knives of a cutting tool in a fixed position when coiled tubing is used to deploy a tool string to cut tubing.
To avoid moving it, we fix it.
Hydraulic mechanical tubing anchor is specially designed to eliminate coiled tubing movement during cutting operations. Both hydraulics and set-down weight are needed to operate the tool. First, to extend the grapple, fluid is pumped through the tool at a predetermined flow rate. Once the grapple has been extended, set-down weight will lock the anchor against the casing wall.
You see?
Here, the hydraulic anchor is being used in combination with a DB underreamer with cutting knives to cut the tubing end of a completion. The tubing can be safely cut without the knives of the cutting tool moving over the tubing wall.
Tubing is cut now using the knives. Pull out of hole.
When the tubing is cut, the anchor will release by simply pulling out of hole.
Interesting. Next.
When increasing pump rate during
also during displacement to diesel, we have to reduce the hydrostatic pressure on the formation to allow the well. We have leak in the stripper. As I told you, we have to this one. It happened similar with us. You see, we have to close the BOP, stop coil tubing, close BOP, bleed off pressure above it. Then we inflow test the BOP. If it is okay, we can replace this stripper and make it safe. Then open the BOP after equalizing the pressure. We do pressure test here in this section and ensure that the new stripper is holding pressure. After that, we can continue our operation. Here, the last case, we will finish our introductory session. while running coil tubing, pumping at 1.5 barrel per minute, we have this coil tubing got rupture. What will happen? This one, similar to this one, you see. In this case, we have to secure the well, close BOP, slip and pipe rams. After that, we can cut piece of this one here and make a double end connector. This is double end connector, you see it. Piece with coil tubing in the well, and piece will be with the coil tubing on the reel. After that, we ensure do pressure test and increase the pressure and ensure it is holding pressure. And after that, we can start open BOP and start pull out of hole and secure the well and make all the coil tubing on the reel. Then the reel will be thrown away and run another one. But you see how much it is dangerous. Nobody should be working here in this area because it is very dangerous. Imagine if there is acid inside the coil tubing and it falls down on anyone, it will kill him. So our work is not easy. It is not safe 100%. So we have to take care and make sure we are following procedures. We are following the principles that can protect ourselves, we protect the environment, equipment, the company reputation, all of these, because everything you are responsible for it as a operator or a supervisor. So in this case, we finish our introductory session course that will start on 10th of next month.